So every time you draw the Lewis structure of a compound, you have to show if the atoms in the compound are any charge other than zero, because the atoms can be a negative charge or a positive charge. There is a formal charge formula and a formula charge table. You can use either or, but normally the formula charge formula over here, we use it for atoms that are not in the table, like atoms that are different than carbon, nitrogen, and oxygen. So to go over this table, and again, those two you don't need to memorize them. We can have those in the cheat sheet as well. So carbon always makes four bonds to be a zero charge. Carbon is in group number four. It has four valence electrons. So carbon has four bonds. It is a zero charge. If you want carbon to be a plus charge, then it needs to have three bonds, no lone pair. And if carbon has three bonds and one lone pair, it is a negative charge. Again, you don't have to memorize this, but you can get these charges either by knowing this table or by simply using this formula. I'll show you how to use it in a second. Nitrogen, to be a zero charge, it needs to have three bonds and a lone pair. If it's four bonds, no lone pair, it's a plus charge. If it's two bonds and two lone pairs, it is a negative charge. You will learn how to know these with practice. Oxygen, normally it's two bonds and two lone pairs, no charge. Three bonds, one lone pair, it's a plus a charge, and one bond, three lone pairs, this is a negative charge. So the question will be, okay, these are more practice on Lewis structure. The question will be, okay, you're given this molecule, go ahead and draw its Lewis structure. Because within the Lewis structure, it's not necessary that all the atoms in the structure are zero charges, as in the examples that we did before. So let's do the valence electrons. Since we're drawing the Lewis structure, we have two nitrogens, and each of the nitrogen has five electrons, because nitrogen is in the group number five, and oxygen is in the group number six. So this is 16 valence electrons. Okay. Now I'm going to go ahead and draw the Lewis structure. One very important note, you guys. So we said that the unique element is in the center, right? And we said something else, that your central element has to be the least electronegative. The least electronegative. This is what we said, right? Oxygen is not the least electronegative, even though it's unique. It's the nitrogen. So one of these nitrogens is going to be the center. And then the nitrogen is connected to an oxygen, and then another nitrogen is connected to a nitrogen over here. Okay, this is it. So it's as I read it. It's N2, so I start with an N, another N, and then it's an L. Okay. Again, why nitrogen is one of the nitrogens is in the center? Because nitrogen is less electronegative than the oxygen. So far, I've used four electrons. I still have the leftover from the 16. So for 5, 6, 7, 8, 9, 10. Okay. So I am done from the 8 electrons of the first nitrogen. 11 before doing the central. Don't do the central. You need to do the oxygen. 11, 12, 13, 14, 15, 16. Okay, so right now over here, my oxygen is going to be octet. My nitrogen is going to be octet. But see, this nitrogen over here is not. And my total charge for the N2O is 0. But this nitrogen here has no lone pair, so it's not octet. So I know that there is something wrong in there. So what I need to do is I need to make sure that the nitrogen there is octet. So I'm just going to take out two electrons from this nitrogen, and I'm going to make a double bond. The two nitrogens can make double bonds with respect to each other. But if I do this, then see what did I have over here. I have the nitrogen having 1, 2, 3, 4, 6 electrons. I have 6 electrons on the nitrogen. This nitrogen is still not octet. And uh, it lacks lone pairs to be a zero charge, right? So I need to figure out a way. And right now, this oxygen here has one bond and the three lone pairs. So its charge is negative, and my total charge of the structure is zero. So I have to do something with the nitrogen. Maybe if I can do a positive charge on the nitrogen, make the nitrogen four bonds. The bonds they don't need to be all single. I mean, they can be triple bond, three bonds on top of each other. And to do this, I'm going to take two electrons from here and I'm going to make a triple bond in there. This way, the nitrogen will have one, two, three, and four bonds. So it's similar to this case here. Then this nitrogen is going to be a plus charge. The charges are part of the Lewis structure. So what I just drew is a Lewis structure, and these are the charges in there. Plus minus is a zero charge. So this is the true Lewis structure for the N2O. These are, by the way, the hardest it can get, where you have the tendency of making double bonds and the triple bonds in there. So nitrogens can make triple bonds with each other. That is a plus charge, that is a negative charge. Now, I can use this table to determine the charges, or I can use this formula in here. How do you use the formula? It's straightforward. The formula is the number of valence electrons of the free atom. So you need to pick up the atom that you are calculating its valence electrons. I'm sorry, its formal charge. So here I'm calculating the formal charge of the nitrogen. So I would say, okay, the number of valence electrons of nitrogen, meaning what the group the nitrogen is group number 5. So that's going to be 5. Let's continue. This is going to be minus half number of bonding minus the non-bonding. So it's going to be minus half the bonding. What are the bonding? The bonding are the actual bonds in there. The bonding is the bonding electrons. So count. Every bond is 2 electrons. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that is minus half of 8. And the non-bonding is the lone pair on the nitrogen. After all, we are calculating the formal charge of the nitrogen. So everything that is related to the nitrogen, I need to put it in here. So that is going to be minus what? Minus the number of the non-bonding electrons. I don't have any non-bonding on the nitrogen, meaning I have no lone pair on the nitrogen. So that is going to be 0. So my answer here is going to be 5 minus 4. So it's going to be plus 1. So this is how I got plus 1 in here. You can get it either from the formula or you can get it from the table. The table is faster. Let's do the formal charge of the oxygen. So let's do the formal charge of this oxygen over here. Okay, that is going to be the number of valence electrons of the oxygen. Oxygen is in group number 6 minus half the bonding. The bonding is just 2 electrons because there's only one bond on the nitrogen. So that is 2 electrons. Okay, because every bond is a 2 electron minus the non-bonding. The non-bonding is 1, 2, 3, 4, 5, and 6. So that is going to be 6. So your answer here is going to be 6 minus 6, they cancel. So it's going to be minus 1. So see, the oxygen is a negative 1 in there. So you either use the formula or you use the table, whatever one you use. It's fine. It's fine. Just make sure that you know how to use both. This is another example in here. And the question is, go ahead and draw the Lewis structure of C2H4 and make sure that you indicate all the charges of every single element in there, because this is part of the Lewis structure. Guys, when you draw the Lewis structure, if you don't show the plus and the minus, your Lewis structure is missing something. So just make sure that your Lewis structure shows all the charges in there. C2H4, we're going to calculate the valence electrons. This is group number 4 plus I do have 4 hydrogens, and this is group number 1, and it's going to be 12 valence electrons. Okay, hydrogen can never be in the center, so definitely the carbon is going to be in the center. The rule says that whenever you have more than one carbon in your structure, always make sure to start connecting the carbons together. This is it. So let's say if you have 2 carbons, 3 carbons, 4 carbons, you're just going to make a chain of carbons and you're going to connect those to each other. And then now the hydrogens, pay attention. Every carbon makes 4 bonds. This is what you need. This is your target. Every carbon makes 4 bonds in there to be a 0 charge. So I have four hydrogens in there. So I'm just going to go ahead and do two hydrogens. I'm going to divide the hydrogens in half between the carbons because it doesn't make sense that one carbon takes three hydrogens and another carbon takes one hydrogen. Just doesn't make sense in there because one carbon will have less bonds than it should. So right now, if I divide the number of hydrogens to the carbon and say, okay, every carbon will take two hydrogens, I didn't distribute yet my 12 electrons. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I still have two electrons, right? So if I still have two electrons, what I'm going to do is that two electrons is a bond. So I'm just going to go ahead and put this as a double bond. This way, I will make sure that this carbon has four bonds and this carbon has four bonds. So I am good. Each of these carbons is a zero charge. This is another example in there. Um, valence electrons is equal to 2, 4 plus 2, and group number 1. This is 10 electrons. So the reason why I'm doing these examples is just to push on the idea that carbons make four bonds in there, whether in the form of a single bond, this is a double bond, or with this one, say I do have two carbons, so go ahead and put the two carbons next to each other and then divide the hydrogens among the carbons. Each carbon will take one hydrogen. So far I've used 1, 2, 3, 4, 5, 6, right? I still have four electrons. Remember, every electron is a bond, and I need four bonds for each one of these carbons. So I can simply add a bond here and add another bond in there and make a triple bond. In this way, each carbon will have four bonds. And the total number of electrons here is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10. So it's going to be 10 electrons. This way, the carbon will be a zero charge. The hydrogen there, hydrogen is always zero charge. So I am good. This is going to be my Lewis structure. Now let's have another example, but now this is an ion. This is a nitrite ion. And I want to draw the Lewis structure for this one and assign the formal charges. So we want to see this negative charge. This negative charge is the sum of the total charges of the NO2. So at the end, you should end up having, if there's a lot of charges in the NO2 structure, they would end up being a negative charge. This is the sum of all the charges of that structure. So we want to draw the Lewis structure. To draw the Lewis structure, we're going to calculate the valence electrons in there. But now we have something new, which is this negative charge that we would need to take into consideration when calculating the valence electrons, you guys. So now nitrogen is in the group number 5 plus oxygen is in the group number 6. I can't stop here because the whole NO2 is gaining one electron, right? So if it's gaining one electron, I need to represent it by plus 1. This is gaining one electron. So I have to add plus 1 in there, or else the valence electron is going to be an odd number. So just pay attention to that. Valence electrons cannot be odd numbers, they are even most of the time. So my answer here, it's going to be 18 electrons. If you did not add that plus 1, it's going to be 17 electrons. So you would know that there is something wrong. Okay? So now I have nitrogen, oxygen. Nitrogen is the least electronegative. So now nitrogen is going to be the central element. It is the unique one. And then around the nitrogen, I have two oxygens in there. I'm going to start by distributing the 18 electrons. So far I've used 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then 17 and 18. So I have my 18 electrons, but I don't have the right to charges. See, because these two oxygens are both negative, because when oxygen has one bond and the three lone pairs, it's a negative and another negative. But this nitrogen here, it's missing a lone pair to be negative, and I don't want it to be negative because this way I'm gonna have a negative, negative, another negative. So this is a 3 negative, and I have only one. So I would need to relocate the lone pairs, one of the lone pairs, to make sure first that all the atoms are octet. This is octet, this is octet, but this one is not octet. It's not 8 electrons. So if it is not eight electrons, this is an easy fix. I take 2 electrons from the oxygen and simply add a double bond on either sides. It doesn't matter. Either the right, you could have taken this from the left, It doesn't matter in there. So now when I did this, now this nitrogen is a zero charge. Okay, so that nitrogen now is a zero charge. This oxygen has 2 bonds and 2 lone pairs. So 2 lone pairs, 2 bonds. So it's here. It's again a zero charge. I'm good. So my only negative charge is this guy in there. It's the oxygen with the lone pair. This way, I've distributed my 18 electrons. I made sure that every element in here is octet. And I made sure to follow the charges in there. Nitrogen, 3 bonds and the lone pair is a zero charge. Oxygen, 2 bonds, 2 lone pairs is a zero charge. And this oxygen, 3 lone pairs and 1 bond is a negative charge. And this is why your total charge of the molecule is a negative. You can use again this chart to calculate the negative charge of the oxygen or to find out which is negative, or you can calculate it from here simply by using the formula. The formal charge of the oxygen is equal to 6 minus half. The bonding is going to be 2 and the non-bonding is going to be 6, and that is equal to minus 1. Let's do another example, which is similar, SO3 2 minus. So the first thing I would do is calculate the valence electrons for the sulfite ion. It's going to be 6 plus 3 multiplied by 6. So see now, it's gaining 2 electrons. So I have to add 2 electrons. I have to add 2 electrons. Guys, if it was positive 2 electrons, then I need to subtract 2 electrons because positive is losing. So you subtract. You look and see how many electrons you're gaining and losing, and simply apply that to the valence electrons. So now my valence electron is going to be 26. Have you noticed? All valence electrons are even. They are even in number. Okay. Let me put a line in here. Okay. So now we're going to go ahead, put the unique element in the center and put the oxygens in there. I have 3 oxygens. I need 2 negative, okay? And I know that oxygen with a bond and the 3 lone pairs is a negative charge. So I need 2 of those. I need 2 of those. And I want to make sure that the sulfur is a zero charge as well. But remember that sulfur violates the octet rule. So I don't care about sulfur following the octet rule there. So far I've used 6 electrons around the sulfur. So let's go ahead and fill in the rest up to 26. So here you go. This is up to, okay, this is 24, 25, and 26. So I filled up all my valence electrons in there. Now, I cannot leave it like this because if I leave it like this, all of the 3 oxygens there will be negative. All of them, they're going to be negative. So this is 3 negative. I have 2 negative. So what I'm going to do, I'm going to take 2 electrons from here and I'm going to put a double bond in there. So with this said, the oxygen is a zero charge. Let's check the formal charge of the sulfur in there. That is going to be 6 minus half the shared. The shared is going to be 1, 2, 3, 4, 5, 6, 7, 8 minus the unshared, which is equal to 2. So this is going to be 6 minus 4 minus 2. So 6 minus 6, that is equal to a 0. So the sulfur here is a 0, the oxygen is a 0, and each of these oxygens is a negative 1. So you have to put it like this. You have to put it as negative, and this is your Lewis structure for the sulfite ion. That is the, okay, ammonium in here. So this is another example. For ammonium, do the same thing, but now here I have a plus a charge. So valence electrons is equal to 5 plus 4 times 1 minus 1. See, it is now minus 1. Why? Because it is plus 1. You're adding plus 1. You are losing an electron. So you're losing an electron. So this is going to be negative 1 for the valence electrons. And your answer is always even. So this is going to be valence electron. That is even. So I'm going to put the nitrogen in the center, and then around it there are 4 hydrogens in there. Here you go. This is it. I mean, I've used my, this is going to be 10 electrons. It's going to be, let's see, 4, 5. Wait a second. This is 5. This is 8. I don't know why I said 10. I'm sorry. So this is 8 electrons in there. Okay. So it's 5 minus 5 plus 3. This is going to be 8, 8 valence electrons. So these are my 8 valence electrons. And the nitrogen is a plus a charge. Why? Because when nitrogen has 4 bonds, it is a plus a charge. Okay. More examples, more 2 examples for these, the C2H6 and the O3. C2H6, this is 14 valence electrons. There is no charges in these two, so you don't have to add any or subtract any. As I said, whenever you see more than one carbon, this is the first thing that you start with, and you group them next to each other like this. And now I'm going to divide the hydrogens among each carbon. So each carbon will take 3 hydrogens here. This is a hydrogen, this is a hydrogen, this is a hydrogen, a hydrogen, and another hydrogen. You guys, we're done because every single carbon here has 4 bonds. This carbon has 4 bonds, so we are good. Ozone. For ozone, it's 18 valence electrons. There is no central atom in here, so it's just like the 3 oxygens that are connected to each other. Okay, so one of them is going to be the central there. And so far I've used 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. This one is octet, this one is octet, but this one is not octet. So if it is not octet, then what I can do is I can take 2 electrons from here, and I can make a double bond in there. So if I make a double bond here, then this oxygen has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So all of those are octet. Now I need to make sure that the charges matches the zero charge of the O3. O3 is ozone. So this oxygen is a negative charge from the table because it has 1 bond. This oxygen here has 3 bonds and the lone pair, so it would be a plus a charge. And this oxygen is 2 bonds, 2 lone pairs, refer to the table, okay? So that is a zero charge. You don't have to mention the zero charge there, but here you go. The positive and the negative will cancel out and will make ozone being a zero charge.